Assalamu alaikum. In this video, we are going to solve the equations which are reducible to quadratic form. So the equations given in exercise 1.3 are not themselves quadratic. We are going to make them in the quadratic form. So how we are going to make in the quadratic form? By applying some substitution. Let's see in the first question. 2x raised to power 4 minus 11x square plus 5 equal to 0. This equation is actually called biquadratic equation. So what substitution we are going to make? We'll suppose let y is equal to x square. So instead of x square we will write y. So we'll just make one substitution, and out of that substitution we'll find out the value of other powers of x also. So the whole equation either be in x or either it will be in y. So if we take the square of on both sides of this substitution, we'll get x to the power 4. So our equation will become, equation 1 becomes now 2. Instead of x raised to the power 4, we'll apply this, which is y square. Instead of x square, we'll write y plus 5 is equal to 0. So we have made the equation that was originally a biquadratic equation. So we have reduced it into quadratic form. So you see we have applied just one substitution, and out of that substitution we have changed the whole equation from x to y. Now the equation is the standard quadratic equation, so you can compare it easily. Now you can apply any of the method. You can either use factorization method, or you can break the middle term, or you can apply the completing square method, or you can even apply the quadratic formula. So let's see if we can break the middle term. Yes, we can break the middle term. Middle term can be broken down into two terms like minus 10y and minus y. So I hope you all remember the middle term break factor method. So we'll take minus 1 common. We got two factors, y minus 5 and 2y minus 1. So once we'll write either 1 times y minus 5 equals 0 or 2y minus 1 equals 0. So y is equal to 5 and y is equal to 1 by 2. So you see these two are actually the values of y, but our equation is in x. So we have to find out the values of x. So what we are going to do, we inserted y instead of x square, so we'll return its value. We'll do the back substitution. So now instead of y we'll write x square equal to 5. Here also instead of y we'll write x square equal to 1 by 2. So we just have to find out the value of x square. So we'll take square root on both sides. Comes out to be, square will get cancelled by its root, plus minus square root 5, and here we'll also get plus minus square root 2. Okay, so we have taken square root on both sides. Now the solution set we have to write at the end. Comes out to be plus minus square root 5 and plus minus 1 by under root 2. So you see, by applying certain substitution, we are supposed to find out the value of the variable. Let's solve another sum in which we have to reduce the equation to quadratic form. Let's see which type of substitution we'll make here. We'll suppose the smaller term with a smaller power, so that we can, when we'll square it, we'll get the higher power. So let y is equal to x square, and from the same substitution it will square it. Squaring both sides, we'll easily find out the value of x raised to power 4. So you see, from the same substitution we have converted the equation from variable x to variable y. So our equation 1 will become now 2. Instead of x raised to power 4 we'll write y square, and instead of x square we'll write y minus 4. So you see our equation is now converted. We'll just rearrange it. 2y square minus 9y plus 4. Our equation now has become in the standard form of quadratic equation, right? You can easily compare it. So you see, from the same substitution we have converted the whole equation from the variable x to the variable y. Now you can easily break down the middle term. Because we need to find out the value of y now. So we'll just solve it for y. So y minus 4 and 2y minus 1 equals 0. We'll write once either minus 4y, y minus 4 equals 0 or 2y minus 1 equals 0. So y here is equal to 4 and y here is equal to 1 by 2. So originally the equation was in x, we got the value of y, so we have to do the back substitution. What we supposed earlier, instead of x square we'll just write y, so we have to give the value of y back to as x. So instead of y we'll write x square equal to 4, and here also we'll write y, instead of y we'll write x square equal to 1 by 2. So taking square root on both sides, plus minus 2, here also we'll take square root on both sides, we'll get x equals to 1 plus minus 1 by under root 2. So at the end we have to write down the solution set. Plus minus 2 we can write collectively with both signs. So this is the solution of the equation. Okay, let's solve another part. Question number is now 3. 5 x raised to power 1 by 2 is equal to 7 x raised to power 1 by 4 minus 2. Now what we have to do, again we are supposed to reduce the equation to standard form, standard quadratic equation. So how we are going to reduce it, we'll make another substitution. Let's see which type of substitution here we can make. We just have to make one substitution, right? And from that one substitution we have to find out both the values of this power, x raised to power 1 by 2 and x raised to power 1 by 4. See, let's say y is equal to x raised to power 1 by 4. Now you see you have to take the square any case, because in the standard form of quadratic equation we have power of square power of x, right? So we need to take the square on both sides. Once you take the square on both sides, you'll get y square and it will get cancelled 1 by 2. So you see we got the value of x raised to power 1 by 4, we got the value of 1 by 2. So our equation 1 will become now 5. Instead of x raised to power 1 by 2 we'll write 5y square. 7 as it is. Instead of x raised to power 1 by 4 we'll write y minus 2, and we'll just rearrange the equation. So our equation now is converted into standard form of quadratic equation. Now we can easily break the middle term and we can find out the values of y. So I hope all of you remember the process of middle term break factor. So we'll take 5y common, we are left with y minus 1. Here we'll take minus 2 common. So we have to take now whole bracket y minus 1 common. From here you are left with 5y and here we are left with minus 2. So either y minus 1 equals 0 or 5y minus 2 equals 0. So y is equal to 1 and y is equal to 2 by 5. Now since we are having the values of y, and instead of y we have to find out the values of x, so we'll do the back substitution. So we'll write now y was supposed to be as x raised to power 1 by 4 equals 1, and y here was, we supposed it as x equal to 1 by 4, x raised to power 1 by 4. So we have done the back substitution. Now we just need x and we don't need 1 by 4. So how we'll remove this, we'll take the fourth power. You can write take fourth power on both sides. So how this taking fourth power on both sides, we'll take 4, will cancel by its power, fourth root, and 1 into 1 into 1 means 1, so x equal to 1. This is your first answer. And here again we'll take fourth power on both sides, so 2 by 5 whole power 4. Fourth power will get cancelled by its fourth root, and you are left with 2 raised to power 4 means 2 raised to power 4 and 5 raised to power 4, which comes out to be 16 over 625. And at the end you have to write down the solution set, which is 1 comma 16 625 over 625 bracket close. So this is how you are going to solve the question. What we have done, we have reduced the equation into standard quadratic equation by applying some substitution, and then we have solved it further. Now we are going to solve question number 4 of the same exercise. Let's see which type of substitution. Here we are going to make x raised to power 2 by 3 plus 54 is equal to 15 x raised to power 1 by 3. So you need to find out yourself that either you have to suppose initially as y is equal to x raised to power 2 by 3 or y is equal to x raised to power 1 by 3, so that from 1 we can find out the value of other, right? So let's see solution. Let if we take y is equal to x raised to power 1 by 3, so that after squaring both sides you will easily find out the value of x raised to power 2 by 3, right? So equation 1 will become instead of x raised to power 2 by 3 we'll write y square plus 54 as it is. Instead of 15 we'll write 15, and instead of x raised to power 1 by 3 we will write y, which was supposed earlier. And now we just have to rearrange the given equation. Once I have done one mistake, so instead of it, since we have moved 15y to the other side, so now we are going to break the middle term. Let's say 6 times is 54, so we have to break the middle term as minus 9y minus 6y plus 54 equals 0. So we'll take y as common factor. Here we'll take minus 6 as common factor. Again we have to take y minus 9 as a common factor, so we are left with y from here and 6 from here. So now we are supposed to put both factors equals to 0. So either y minus 9 equals 0 or y minus 6 equals 0. So y is equal to 9 and y is equal to 6. But we need to find out the value of x, so we'll substitute back what we supposed earlier. Instead of y we suppose x raised to power 1 by 3 as y. So we have to give the back substitution. Now y, instead of y we'll write x raised to power 1 by 3 9, and here also x raised to power 1 by 3 equals 6. Now we just need out the value of x, so we are supposed to take cube on both sides. Okay, taking cube on both sides, so x raised to power 1 by 3 whole cube, 9 cube. Here also x raised to power 1 by 3 whole cube and 6 cube. Cube will be cancelled by its cube root, and we are left with 9 cube means 9 into 9 into 9 becomes 729. Here also we'll have 6 into 6 into 6, it becomes 216. So at the end you just have to write down the solution set as 216 comma 729. So hope you understand the sum. Let's move it further. The next sum is going to be the fifth sum of the same exercise, in which we have to reduce the equations to quadratic form. What we are doing, we are applying the substitution, and once the substitution is made, the equation is being reduced to quadratic equation. Now let's see here how we are going to suppose. We'll just have to do one substitution, and from that substitution we have to find out the other powers of x also. So let's suppose y is equal to x raised to power minus 1, and when we'll take square on both sides it will become minus 2. So just by one substitution we have found out both powers of x, right? So let's rearrange the equation. So our equation 1 after substitution will become 3 as it is. Instead of x raised to power minus 2 we'll have y square plus 5 as it is, 8 as it is, and instead of x raised to the power minus 1 we'll have y. There is one other method of solving this sum. You can solve it in that way also, but since we are doing substitution, so I have done substitution for you. Again, we are supposed to break the middle term. So which two factors we are going to use? Minus 3y minus 8y becomes minus 3y minus 5y, and that becomes minus 8y, and if you multiply the two factors you will get 15. So we will take 3y as common, y minus 1. Here we'll have minus 5 common, y minus 1. So y minus 1 will take common, 3y minus 5 is common, is equals 0. So next we are supposed to equate both factors equal 0. So we are having y minus 1 equals 0 or 3y minus 5 equals 0. Y equals 1 and y is equal to 5 by 3. So we need to find out the value of x. So we'll substitute it back. Now y, instead of y we write x raised to the power minus 1, and here also instead of y we'll write x raised to the power minus 1. How we are going to find it? The value of x, if you just take the reciprocal. What is x raised to the power minus 1 actually? It is 1 by x, right? So instead of x, you can even find out the cross multiplication you can do, or you can simply write x equal to 1, because 1 by 1 is again 1. Again, if you want to take the power of positive power, you can even take the minus 1 power on both sides, or even if you know the properties of index the property, if you know that, you can just take the reciprocal. It is actually this, and you just have to take the reciprocal on both sides, so you get the value of x. So then you just have to write down the solution set, that is 1 and 3 by 5. So hope you understand the sums. So these were not actually the quadratic equation, but the equations were reducible to quadratic form by applying some substitution. Hope you understand the question. Thank you so very much. Solve few more sums of exercise 1.3, in which this type of equation it is not again in standard quadratic form, right? So we are supposed to convert it into the standard quadratic form. So if you see, we are having 2x square plus 1 and 2x square plus 1 same terms, so we can easily write it, suppose it as y. So we'll write 2x square plus 1 as y. So our equation 1 will become y plus 3 by y equals 4. So still our equation is not in standard form. So how we are going to convert it? We'll multiply the whole equation by LCM, and here LCM is y, so we'll multiply it by the whole equation by y. So when we'll multiply the first term by y, we'll get y square. When we'll multiply the second term by y, it will get cancelled. Let me show you that step are working. All the steps are working, so you can easily find out. So we have to multiply the whole equation by LCM, and LCM in this case is y, so we have multiplied the whole equation by y. So it becomes y square, will cancel, we are having 3 and we are having 4y here. We'll just rearrange our equation. So you see now the equation is in the standard form. So what we are supposed to do here, we are supposed to further factorize it so that we can take out the value of y. So which two factors we are going to use? We'll break down the middle term, minus y minus 3y plus 3 equals 0, and again we are going to take the common factor. We are having y minus 1, and y minus 3 equals 0. So either y minus 1 equals 0, or we are having y minus 3 equals 0. So we'll be having y equal to 1 and y equal to 3. So actually this is not the complete answer. So what we supposed y as, it was 2x square plus 1 initially. So we have to do the back substitution. So instead of y, now we will write 2x square plus 1. And again instead of y, we'll write 2x square plus 1 equals 3. So now we just have to solve it further. We just have to simplify it. 1 minus 1. So we are having 1 minus 1, we can cancel 0. 2 is here multiplying. On the other hand side, it will get divided by 0. Then we'll get 0 and we'll take square root on both sides and you will be getting 0. Let's solve the other factor, which was now 3 minus 1 and then 2. Then 2 will be divided by 2. We are having 1. We'll take square root on both sides and we are having plus minus 1. So we got the values. Now we are supposed to write down the solution set 0 and plus minus 1, which is the answer, right? Hope you understand the sum. You can write the answer collectively and you can even write down the answer separately with separate signs, plus minus 1. Let's solve another sum of the same type. Let's say it is question number 7 of the same exercise, that is x over x minus 3 and plus 4 over x, 4 into x minus 3 over x equals 4. Now again we have to do the substitution. What will substitute? Let's say now in this case just take first term as a substitute. Y is equals to x over x minus 3. From the same this substitution we have to find out the other value. So if you see, if we'll take the reciprocal of both sides, 1 by y, and it will become x minus 3 over x. So you see, you got the other term, the value of the other term as well in y. So our equation 1 will become now, instead of first you will write y plus 4 as it is, and instead of x this term we'll write 1 by y, or even you can write directly as 4 by y equals 4. Now what you have to do, again it was the same as we got in the previous question. We have to cancel this y so that we can convert the equation to standard quadratic equation. So we'll multiply whole equation by y. Now I am writing directly. It becomes 4 and it becomes 4y. And then we'll just rearrange it. And if you see what it is actually the second algebraic identity, and this y minus 2 whole square equals 0. So you see y minus 2 equals 0, y minus 2 equals 0. So we are having the same factor. So we'll just write once, right? So y minus 2 equals 0 and here y equals 2. Now instead of y, what we supposed earlier, and that was x over x minus 3 equals 2. Now we have to find out the value of x. We'll just do the cross multiplication as we are having one fraction on both sides of equal sign. So here x will remain here and 2 will get multiplied by x minus 3. You will just have to expand it. Let's say we'll take 6 to the other side so that our x will remain positive. So x equals 6. The solution set is 6. Okay, so our solution set here is 6. I hope you understand this sum. Let's solve one other sum of the same type, and that is going to be question number 8. So it is 4x plus 1, 4x minus 1 plus 4x minus 1 over 4x plus 2, plus 1 is equal to whole 1 by 6. So which type of substitution we made in the previous sum, question number 7, the same type of substitution we'll do here, right? So we'll just suppose this as y equals 4x plus 1 over 4x minus 1. And again we'll take the reciprocal on both sides. It will come 1 by y, and the other hand, on the right hand side, we'll also take the reciprocal, and while taking the reciprocal we got this term, value of this term. So our equation 1 will become y plus 1 by y, and this is a mixed number, so we'll convert it. It becomes 13 by 6. So again we are supposed to make it in the standard form. This time we have to multiply the whole equation by 6y. So I'll write directly now. It becomes 6y square. It becomes 6 and it becomes y. So we'll just rearrange it. it becomes minus 13y plus 6 equals 0. So we are supposed to break down the middle term. 6 into 6 become 36, and we have to find out the factor of 36, which will make 13 ultimately. So we have used 9 and 4 as the factors, right, of 36, because 9 4 times is 36 and 9 plus 4 is 13. So now we'll just take the common factor. Here 3y is the common factor, and here 2 is the common factor. So we are having 2y minus 3, and we are having 3y minus 2 equals 0. So we'll write both factor 1 by 1 equals to 0. We are having 2y minus 3 equals 0 and 3y minus 2 equals 0. From here we have y equal to 3 by 2. From here we have y equals 2 by 3. Right, so what we are going to do next, we'll do the back substitution. What we supposed earlier as y, we have to give it back, return it back, return the values of y as 4x plus 1 and over 4x minus 1 equals 3 by 2. It is a bit lengthy because originally y was a very big fraction. So we just have to do this, you just have to be very much careful about this fraction 2 by 3. So one it is 3 by 2 and another time is just 2 by 3. So how we are going to solve it? Since we are having one single fraction on both sides of the equal sign, we'll just do the cross multiplication. 2 into 4x plus 1 and 3 into 4x minus 1. Let's solve this factor first. 4 times 8 plus 2, 4 times 12x minus 3. So we'll just take 3 to the other side, so x will remain positive. Here we have 5, and here we have plus 4, and x is equal to 5 by 4 is going to be our answer, right? First answer. Now let's do the cross multiplication for on the other factor. 3 into 4x plus 1 and 2 into 4x minus 1. 3 4 times 12x plus 3, 4 times 8x minus 2. Let's remain our x positive. 12 minus 8 is 4x minus 5. So here x is equal to minus 5 by 4. So if you see, once we'll get minus 5 by 4 and time we'll get plus 5 by 4. So at the end you have to write down the solutions, and you can write it separately, or even you can write it collectively as plus minus 5 by 4, which is the answer. Hope you understand the sum. Let's solve the sum. One more sum of this same type, which is question number 9. So x minus a. This is actually the journal form of the previous one. Previously, instead of a, we were having digits. Now we are having a. A can be any number. So how, again, we have to make some substitution. The substitution method will remain the same in the type 2. Instead of, let's say, first term, we'll write y. That y is equal to x minus a over x plus a. When you will take the reciprocal on both sides, the fractions will turn upside down, and you will get the other value of the second term as well. And then your equation will reduce to the quadratic form. So equation 1 will become x, instead of first term we'll write y, instead of second term we'll write 1 by y, and it becomes 7 by 12, right? So now we are supposed to convert this equation to standard quadratic equation. We have to remove y and 12. We'll multiply the whole equation by 12y, and now I'm going to write it directly. So first term multiplied by 12y becomes 12y squared. Second term multiplied by 12y becomes just 12. Last term multiplied by 12y becomes 7y. So we'll just rearrange it further. Okay, now we are supposed to find break down the middle term. 12 into 12 becomes 144, and we also need here as 7. So we'll use the factors as 16 and 9, right? So minus 16y plus 9y minus 12, right? So let's say 4y is the common factor. Here we are having 3 as the common factor. So 3y minus 4 and 4y plus 3 equals 0, right? So we'll equate both these factors. 1 by 1 equals to 0. 3y minus 4 equals 0, or 4y plus 3 equals 0. Here we are having y equal to 4 by 3, and from here we have y equal to minus 3 by 4. Now what we are going to do, we'll resubstitute the values. What we supposed earlier as y was x minus a over x plus a equals 4 by 3. And for the other factor, y is equal to x minus a over x plus a minus 3 by 4, right? So we just have one fraction on both sides of the equation, equal sign, so we'll just do the cross multiplication. So this was same as what was previously done in the previous question. So 3x minus 3a, 4x plus 4a. So let's say we'll just make our x positive, so we'll take 3x to the other side. We'll be having minus 7ax. So we got one value of x. Let's solve the other factor. Again we are having single fraction on both sides, so we'll just do the cross multiplication. X plus a, we just open up the brackets, we'll just rearrange the terms, and we'll be getting the values of this. Here again we just want to have x as positive. Let's say our x will remain positive. We are having 7x and we are having a over here, so we just need the value of x, don't need 7. So 7 will go to the other side, and then so we are having a by 7 here. So we got two values, solution set. At the end you have to write, it becomes minus 7a comma a by 7, right? Hope you understand the sum. I have done each step of working for you. Still, if you don't understand any step of working, you can comment or you can ask me, right? So thank you so very much.